Alright, so let's take a look at these later problems, the matching. Here they're asking us to match this exponential function to one of the graphs. So what can we expect? What do we see here? The base 5 over 2. This base of 5 over 2, well, half of 5 is 2.5. So with the base being greater than 1, this is an increasing function. So if we kind of sketch it, these exponential functions are like this. There's no other transformations on this. So our horizontal asymptote is the line y equals 0. There is no vertical asymptote. If you plug in just a few key points, when your exponent is -1, what will y be? Well, when that exponent is -1, it flips this fraction, and you'll have 2 over 5. And as a decimal number, 2 over 5 is about 0.4. When this exponent is 0, this base raised to the 0 power is equal to 1. And when this exponent is 1, you'll have 2.5. So I'm just going to call these points A, B, and C. And if this is -1 and 0 and +1, then on my graph, this point A, this y-intercept I call point B, and 1, 2.5. Imagine that height above the x-axis is 2.5. That would be point C. So this is the shape and a few of the points that we're looking for. Let's see if we can't determine, well, here. I can't really copy that. So it was like this. Clearly it's not A, it's not B. The general shape is increasing like C, but however, it's not going through the point 0,1, so it's not C. This D, you can tell that the exponential function has been lifted up, but for ours, there's a +0, so it's not D. E is the correct shape. It's going through the y-intercept of 1. F is not going through a y-intercept of 1. Appears to be point E. Let's look and see if we read off 1 is at about 2.5. So if we come down here at 1 and look at this point up here, it does appear that it's following our table. So just process of it can't be these others because the others either don't have the correct shape or are not passing through that correct y-intercept. So for number 5, it's E. Let's take a look at number 6. Well, we know that number 6 is going to be related to this graph of E. Alright, so from number 5, we know that this 5 halves raised to the x power has a graph that looks like this. Well, if we take a look at number 6, they're almost the same graph with except this negative sign. We know that negative sign is a reflection. It's not a negative sign that's changing the domain because it's not in front of the x. It's not within our input, so it's changing the y-coordinate. So it's a reflection across the x-axis. So among our choices, we're looking for something that's coming along, and instead of going through the point 0,1, it's going to go through 0, -1, and at 1, rather than going 2.5, it's going to be -2.5, and it's going to look something like this among our choices, a reflection across the x-axis. So we've already answered that E was number 5, and we're looking for a reflection of that across the x-axis. And it appears to be A up here. If I look at 1, it looks to be down here at about 2. Yeah, so the B is clearly not a reflection of choice E. C is not. It's some type of a shift to the left, and there's a shift up, and there's a shift to the right. So yeah, it's got to be, this number 6 has to be choice A among these choices. Alright, so let's take a look again, we have a transformation on that problem number 5. Let's come back and get a copy of the what we know the graph to look like and see how it's transformed for problem number 7. So this was y equals 5 halves raised to the x power, and now we're affecting the domain, and that minus 3 is bizarre. It's actually a shift to the right 3 units. So let's take this y-intercept of 1 and let's move it to the right 3 units. 1, 2, 3, and here this point, say it was some fraction, it was I think it was 0.4. 1, 2, 3, and that 2.5, 1, 2, 3. So we're looking for a graph that has been shifted to the right 3 units. So let's see if we can find that. So we already knew that this was 5, that this was 6, I believe, and so among these, I suppose we could have repeats. So maybe I shouldn't eliminate those just because it was a previous answer. We're looking for a shift to the right, and it looks as if it's point F. If we go 1, 2, 3, yeah. So this guy is point F from that transformation of shifting 3 units to the right. All right. In number 8, this time we have x plus 3. Addition is commutative, so x plus 3. And it's bizarre. You're adding 3, but it's actually a shift to the left 3 units. So let's go with this y-intercept and see if that point is enough. 1, 2, 3. And if we know that we're looking for something like this that has been shifted to the left 3 units among our choices. So if this guy is moving to the left 3 units, let's take a look here. 1, 2, 3. Yeah, the graph of C is the graph of E shifted to the left 3 units. So for problem number 8, it is choice C. So here we have, do I still have that? Yeah. Our parent function. And this, we've seen before the negative out in front was a reflection across the x-axis. Now the negative is in front of the x. What it's changing the sign of the x-coordinate. X controls left and right. So if you're changing the sign of the x-coordinate, this positive 1 becomes negative 1, but the y remains the same. Now, if you're changing the sign of the x-coordinate, it's already 0. The opposite of 0 is 0. So then down here that was like, I don't know, I think it was 0.2, or if this negative 1 now becomes positive 1, so I'm looking for something among our choices that has a graph like that, where the graph of E has been reflected across the y-axis. Alright, so what do we have here? It looks like directly up above it that you have the same y-intercept, but over here this point at 1, 2.5 is now negative 1, about 2.5. So this is choice B. None of the other choices are a reflection across that y-axis. Alright. Now this one looks a little bit different, but it turns out it's more similar than what we first expect. Let's rewrite this problem number 10. This negative exponent. Remember, if I decide to change the opposite of x to just x, then I need to flip that fraction, 5 halves. And that's what we had to begin with, and this plus 3 is going to lift this up 3 units. So this y-intercept, if we go up 3 units, 1, 2, 3, we're up here at 0, 4. And our horizontal asymptote that originally was at y equals 0 also gets lifted up 3 units. So that horizontal asymptote is now at y equals 3. And we're looking for a graph that looks like this, where this guy's getting closer and closer but never touching that. Now, to our eyes, we can't zoom in close enough. It does over here, look as if it's touching, but theoretically it's not. So let's look and see. Well, here it appears to me that this is the one that's been lifted up. And has it been lifted up the correct amount? Yeah. If we look right there, and that's the new horizontal asymptote, and that is going through, your eyes are better than mine, but it's going up through at y equals 3. So this choice is choice D. Alright. So now in the next group, we're changing from the graph of transformations on an exponential function to transformations on a log function. Alright. So this log base 6 of x, I know it's the inverse of 6 to the x. Maybe you're more comfortable in thinking of what that graph looks like and then reflecting it across the line y equals x. This initial one, these parent functions, remember in Skill Packet 4 we memorized the basic shapes of graphs of a constant function, an identity function, a quadratic function, a cubic function, a square root function, a cube root function, reciprocal function. We had about 12 different graphs, and one of them was an exponential and one was a logarithm that we memorized. Now at that time you may not have had as detailed understanding of an exponential function or a log function, but that was one of the 12 basic functions in Skill Packet 4 that we memorized the shape of the graph. So this is an increasing function, this base greater than 1. So if I think, and it's passing through the point 0, 1, and it's increasing. These exponential functions grow really fast. Alright, so, and its horizontal asymptote was the line y equals 0. Well, when you go to think about inverse functions, if this is some function f, the inverse is denoted. That's not an exponent like it is when we're doing other problems, computational problems. This is just notation, function notation, indicating the f, and this is read as f inverse, are inverse functions. And with inverse functions, the domain and range has been switched. And how that'll show up and appear in a graph is the graphs of inverses will be reflections across the line y equals x, a 45-degree line going through there, the identity function. So let's change colors here. This 0, 1 becomes 1, 0. And this this horizontal asymptote of y equals 0, when it's switched, becomes a vertical asymptote of x equals 0. So if you're switching domain and range, you're switching the x-coordinate and the y-coordinate, you're switching the x-axis and the y-axis. Alright, so although the y-axis has the description that every point on the y-axis you have it moved left or right, so the one thing that's consistent with all the points on the y-axis is their x-coordinate is 0. So with a vertical asymptote, our graph gets closer and closer and closer and doesn't touch, just as this part of the exponential graph got closer and closer to it. So this part you can see is a mirror image, and by the mirror we mean the mirror is the line y equals x. It's a reflection across that line. So here, this graph in green is what I'm looking for the graph of log base 6 of x. I know that when you plug, you can't plug a negative number in for a logarithm. because remember, the output of an exponential function is never 0 or negative, so the input, if you switch that domain, if you switch the domain and range, the input of a log function cannot be 0 or negative. So if we input a number like 1 into here, if we have log base 6 of 1, we're asking ourselves 6 to what power is equal to 1? Well, 6 to the 0 power is equal to 1. This log base 6 of 1 is equal to 0. And what about if we inputted 6? If we inputted an x of 6, 6 to what power is 6? 6 raised to what power? Because the logarithm equals the exponent, the power, 6 to the first power. And look here, when x was 1, 6 to the first power 6, the x and y have been switched. So we know that there's a point out here that... So here's 2 points in the general shape that we're looking for. This is not a B, this is a 6, that we're looking for among the choices of our graphs. So let's see if we can find it. I can immediately see that there's 2 possible choices that have the same shape, this G and this J. So it's a good thing that I looked more than just the 1, 0, because both of these have an x-intercept of 1. But if I come out here to 6, this graph of G is passing through the point 6, 1. And over here, this is passing through the point 3, 1. Out here at 6, it's above 1. It's some decimal number. I really can't read it. I'd have to estimate it anyway. So with this base 6, I know that the answer for number 11 is going to be G. All right. So if we know that log base 6 of x had this graph of G, and in number 12, we have a transformation on that graph. This negative sign, it just transforms the graph of G. That negative sign is going to be a reflection across the y-axis. If you're changing the sign of x, what the opposite of x? Well, over here, x was, well, let's go back to our point, 6, 1. The x will now be the opposite. It'll be negative 6, positive 1. And instead of 1, 0, it'll be negative 1, 0. So you can see that the graph that we're looking for is going to look something like this. Actually, I guess I should have done that in another color if I'm... let's just make this the one that we're looking for. So the graph, the parent function was this one in red, and now with that negative sign, we've just graphed the one that we're looking for. Let's see if we can't find that. Oh, there it is right there in L. If I go negative 6, 1, so there it is. So the G had been reflected across the y-axis, and it produces the graph of L. Let's steal this graph and copy it and bring it along with us, because I suspect, yeah, that this is going to be another transformation of this. Well, remember this guy was log base 6 of x, and I don't have an x there, but I know with my properties of exponents that I can put an exponent of 1 right there. Well, if I if I reflect this 1 over x, if I take the reciprocal, not reflect, if I take the reciprocal, I'm going to have to, 1 over x is not the same thing as x to the first power, so I can't claim that they're equal, but I can claim that 1 over x is the same thing as x to the negative 1. So this 1 over x to the positive 1 is equivalent to x to the negative 1. So we have this, all right. Well, now I have a property of logarithms that say that when you have an exponent, you can take that exponent and move it out in front of the logarithm as multiplication. So I can take this negative 1 by the power rule and turn it into multiplication out in front of that logarithm. I can write that as the opposite of log base 6 of x. So now it's easier for me to see what this transformation on this graph is going to be. If we come down and sketch this, the opposite, that's going to be a reflection across the x-axis. So when you change the sign of the y-coordinate, this point was 1, 0. Well, the opposite of 0 is still 0. But let's go back to our point 6, 1 is now going to be 6, negative 1. Okay, so you can see that this portion that was above the x-axis is now below, and this portion that was below the x-axis is now above. So that's what we're looking for, is the shape like this that's passing through the point 6, negative 1, and of course passing through the point 1, 0. So let's see if we can't find that among our choices. It looks here as if that's choice K. Alright. Log base 3 of x. Okay, well, now this is a little bit different. This really isn't a transformation that I can see on the on this graph of g. If you recall, when we were first looking at the choices, G and J were in the running for that very first problem. Which number was that? Number 11. You know, and we ruled this J out because this one was passing through the point 3, 1. Well, if we take a closer inspection now, where'd it go? There. We know that this one is base 6, and this base 6 went through the point 6, 1. So we know that here this log base 3 of 1 is going to go through the point 3, 1. It's going to have the same basic shape. It's going to have the same x-intercept, but out here at 3, it's going to pass through the point 3, 1. So the larger that base is, the more that this graph kind of hugs that x-axis. If you compare the height over here and the height over here, this had the bigger base, and that height is smaller than out here at the same corresponding, I don't know, that's 9 or 10 out there. So this 3, 1, this is definitely going to be the graph of J. And I haven't done a transformation on the original. I just compared the size of the bases, and I noticed a pattern that as the bases increase, that this gets closer and closer to that x-axis. And for the smaller bases, you'll be further away from the x-axis there. Alright, so this is a reflection. We're back to a transformation on this graph. The minus sign there is a reflection across the x-axis. What was up is now down, so this point that was at 6, 1 will be at 6, negative 1, and we're looking for something like that. So among our choices, 6, negative 1, there it is, K. Okay. Now I think that on your paper there's a negative sign right there. Originally, when this worksheet was made without that negative sign, it turned out that this wasn't among the choices, and I'll try to make sure that that doesn't happen, that we won't have none of these. But in this case, without that minus sign, it turned out that it was none of these. But I think, like I say, well, let's just look and see. We have the log base 6 of x, and what kind of, there's two transformations that are going on here. The plus 2 is going to shift this to the left 2 units, so let's sketch that in. So if we go to the left, our x-intercept at 1, 0 becomes negative 1, 0, and our 6, 1 becomes 4, 1, and there's, well, that's so small that it's hard to sketch. Alright, and our x-intercept also moves to the left 2 to where it's at x equals negative 2. Well, then there's a reflection across the x-axis, the opposite of the y-coordinate. What was up is now down. So let's change colors and let's see. if instead of this 4, 1, we're at 4, negative 1, and it's looking like this. So we're trying to look for a shape that looks like that. Let's see if that's enough to. And it looks, well, no. All right, let's be a little bit more precise. If we plug in 4 plus 2 is 6, and 6 raised, let's see, if we plug that in, what's y going to be? The opposite of log base 6 of 6. So in exponential form, but I have to deal with that. Oh yeah, I have to deal with this minus sign. I need to bring it up. 6 raised to what power is 6 to the negative 1. Well, this is negative 1. So there it is right there. I got confused between the colors, between the blue and the pink. So for negative 1, when x is negative 1, when x is negative 1, negative 1 plus 2 is 1. And if we have 1 here, so 6 to the 0, so yeah, it's 0. Alright. Now, at 4, negative 1, yep, it is that one. And at negative 1, 0, no, it's not. There, okay. You're probably yelling at me on that. There's 4, 1, and there's negative 1, so it's M. Alright, sorry about that. See how, oh, and gosh, I'm ridiculous. The shift to the left 2 units. This one has not been shifted to the left 2 units. It did have the reflection, but it didn't have the shift to the left, so yes, it's got to be M. Sorry about that. Alright, so hopefully that helped, with the exception of my blunder here at the very end. It's still pretty early in the morning. Sorry about that. Talk to you later. Bye.